Everybody, I want to take just a moment to review the gas laws and the relationships that you did last week during the simulator activities. So in the first one, with Boyle's law, the relationship is between volume and pressure. So let's balance out here. So if volume increases, the pressure decreases. With this large volume, the pressure is down to 15. If we decrease the volume, the pressure increases. The volume went down from 15 to a little more than 5, and the pressure increased from 15 to almost 42. Okay? So Boyle's law, larger volume, lower pressure, smaller volume, greater pressure. It's an indirect relationship. That's Boyle's law. Charles' law looks at volume and temperature. Pressure we assume is constant. So we'll let that even out there. There we go. So with Charles' law, if temperature increases, so does the volume. Okay. At a higher temperature, 376 Kelvin, which is about 212 Fahrenheit. It's pretty hot. We have a large volume. If we cool the gas, the volume decreases. At 266 Kelvin, that's about, that's pretty cold. That's close to 0 Fahrenheit. Lower temperature, smaller volume. With Charles' law, it's a direct relationship. If temperature decreases, so will the volume. Okay. The next one, Sachs Law. Okay. Sachs Law relates temperature and pressure. So in this law, we're assuming that volume is a constant. Okay. So Sachs Law relates temperature and pressure. So at 300 Kelvin, the pressure here is about 29 atmospheres. If we heat the container, you'll notice that the pressure is increasing. Okay? We're up to 690 Kelvin, pressure 67 atmospheres. Okay? Which, that's 417 Celsius, which in Fahrenheit is probably about 800, a little less than 800. If we cool this down, as temperature drops, which you can see on the thermometer up there, pressure also decreases. Okay? So Sachs law relates not volume, but pressure and temperature. Greater temperature, greater pressure. Lower temperature, lower pressure. Like Charles' law, it's a direct relationship. Okay? The final piece you looked at, the ideal gas law, actually relates 4 things: volume, pressure, temperature, and now the mass of gas. Okay? And I had you use it just to look at the mass of a gas, and gases have mass just like any other matter, and the pressure. Okay? So if we add some gas here, we have 237 of the particles. You can see that right here. And the pressure is at about 27. Okay. If I add more, I'll use the arrow here to do that. I'll increase to over 400. You'll see the pressure has increased to above 50. I'll add 100 more. The pressure has gone up to over 60. Okay, so with gases, the greater the mass, the more pressure is exerted because we have more particles here colliding against the walls of the container. If I remove some of these, if I remove a bunch, pressure decreases. Okay, so with mass and pressure, more mass of gas, greater pressure. Less mass, less pressure. Okay. All right, everybody. So those are your relationships. You want to use this information as you answer the questions in the video lab. All right, everybody. Here's a syringe. Air's been drawn into the syringe. Next, I'm going to put my thumb over the end of the syringe, the open part, and I'm going to try to compress the air. Notice the volume went from 30 to below 10 milliliters. Now it's at about 5 milliliters. There's a lot of pressure against my thumb right now. So as the volume decreases, pressure increases. Notice there when I let go of the syringe, the plunger was immediately pushed back out again. Water's been placed in the bottle. The cap has been tightly sealed on. And notice what's happening to water with a small hole in the side of the bottle. Keep in mind here the cap is on very tight. I'm going to remove the cap now and take a look at what happens. Put the cap back on, we'll see. There we go, the cap is now tight on the bottle. So think about why the difference between the two.